of our three-phase motor controller. Have a crappy breadboarded control setup here. Drivers. The IGBTs with snubber capacitors on them. Bus bars. 12-volt battery there at the desk powering the system. And a bench supply here at 30 volts powering the rails of the IGBTs. It is on right now, blinking away. Turn on the voltage here of the bench supply. Put a oscilloscope probe on there. And there's the output of the IGBT right now. See if I can adjust this a bit. If I adjust the speed, sometimes it becomes very hard for the scope to synchronize. Try to hook the probe up constantly for a second. Change the speed here. It's all the way down to 0. There we have almost no... a little finicky. There we have almost no speed. See that the duty cycle is pretty close to 50%, and there's very little fluctuation because I'm in volts over hertz mode, and I am hardly varying the voltage at this point. As I turn it up, you can see that the difference in duty cycle is cycling larger now. And there's a pretty large difference in duty cycle. Not going very fast yet in hertz. And just keep going up faster and faster. So that's it for now. Haven't tested with a motor, but it appears that the pulse width modulation is correct and accurate, and that the IGBTs are operating normally, so we'll try it on a motor preview. Alright, here's another test. I'm going to use a light bulb to test the output of the transistors here and see what the transistor is doing. It's an easier way than blowing up the motor. Turn that up, you can see it's dim, but it seems to be flashing rapidly. It's a little brighter. Now it's finally doing what it was supposed to be doing initially, and flashing. To figure out why it doesn't seem to oscillate properly at low power. But now it is. As I turn this up, it goes faster and faster and faster. Until you finally can't see it flicker anymore. Back down. Slow flash. Test each transistor output. Slow flash. I think the other side is a high power bulb on this. Yeah, there we go. Quite bright and pulling upwards of about 2 amps off my power supply. I'll have to figure out why it doesn't oscillate properly at first, only at about starting in the mid-range. But then it works just fine. It does.
All right, how do you go faster?
So there it is. Spinning this motor barely. I mean, I can stop it with my hands.
Can you increase the voltage?
There it is, a little quicker.
Okay.
Motor's a pile of junk, but
that's okay.
it's spinning up.
What do you want for a free motor from a neighbor?
And now it's got some torque to it.
How much speed can you get out of it?
I should be able to double rev it. I can go up to 120 hertz where this was meant for 60. So I can double the speed of rotation.
You want to try it? Keep an
to
eye
make it go about 3,000 RPMs at that point.
Spin her up. What'd you do?
I'm not sure. Something tripped.
I heard something go click. Oh, something clicked in the motor.
Yeah, the motor messed up.
I think the motor has a breaker switch. Motor probably has a relay switch in it that you tripped because of the hertz imbalance.
Yeah, it didn't like going that fast.
Alright, so just get it up to whatever speed you feel comfortable with.
See, I can control the speed here with this potentiometer. Turn that way down.
Now, we can damage this motor if we run it at too low a voltage, correct?
No, you can only damage it if you spin it too fast or something. Or if I'm driving it improperly and blowing the phases way out of balance, then you might be able to damage it.
Alright, then what made it shut down?
It certainly didn't like going that fast. I don't know if it was a...
What's the RPM of the motor, 1800?
17 something?
Well, no, you can't go any faster than that. Bring it up a little speed.
It's rated for 60 hertz, and I was definitely going over 60 hertz.
Alright, crank it up a little bit.
It might not have liked that.
Do you have any way of checking the hertz that you're kicking in now?
Not right now. I would need to look at it on a scope or something.
A little more speed. A little more. A little bit more. Alright, that's right there. That's about what it's rated for, I can tell you that right now. It's about 800 RPM. It's rated for 17.
Rated for 1700 RPM.
All we gotta get the motor over here, you clamp it on there and power it up.
I guess you can try.
What's it gonna hurt? Shouldn't hurt it, should it?
Haven't blown it up yet.
Now I need to measure the diameter of the rotor on the truck, because that matters apparently.
You're on, and we decided to try this on the actual motor that we're going to be using in the car to see if our homemade controller is operational with this motor. And this is a much larger, higher horsepower, three-phase motor. What is it, 80, 90 horse?
Yeah, it's 67 kilowatts.
But it's supposed to operate at just about any voltage up to 400 volts.
250 is its nominal voltage. I saw it wanting to try, but it couldn't. There it goes.
Okay. It all of a sudden took off. Hold. You got a phase imbalance, and I saw sparks.
Yeah, I saw that too.
Disconnect your wire. I smell smoke. Well, that didn't work. I guess we're going to figure out what happened and get back.